Okay, we are going to start chapter 10 now, and the topic in the chapter is quadratic equations. We've already done some things with quadratic equations, and in the book they've talked about quadratic equations all the way going back to chapter 6. So this is just going to be some more of that. Now, when it comes to solving a quadratic, the only method that we know so far is factoring, okay? And not all equations are going to factor nicely, so there is more to know with that. Now, of course, a quadratic equation is an equation in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not 0, okay? We've already been doing lots of factoring so far, and so the first problem here is it's kind of some factoring warm-up problems here. Part A, let's solve 2x squared minus x minus 3 equals 0. So that's going to factor nicely as 2x minus 3 times x plus 1. There wouldn't be a lot of guessing and checking with this, right, since the factors of 2 are 2 and 1, and the factors of 3 are 3 and 1, okay? When you set each of the factors equal to 0, 2x minus 3 equals 0 means that if you add 3 and divide by 2, x would be 3 halves, and then x plus 1 equals 0 means that x is negative 1. You always have two solutions to a quadratic, okay? So keep that in mind when you're solving a quadratic. There should always be two answers. Part B is another factoring type deal. Now there'd be more guessing and checking with this, since the factors of 6 would be 1 and 6 and 2 and 3. The factors of 3 are 1 and 3. So if you try 3 and 2, 3x times 2x is 6x squared. Negative 9x minus 2x would be negative 11x in the middle, and then negative 1 times negative 3 is 3 at the end. Okay. Set the factors equal to 0. 3x minus 1 equals 0 means that if you add 1 and divide by 3, x would be 1/3, that'll be one answer. 2x minus 3 equals 0. If you add 3 and divide by 2, x would be equal to 3 halves, that would be the other answer. Okay. Problem 2, again we're going to solve. So now in part A, we've got the difference of two squares, right? 7 squared is 49. So x squared minus 7 squared would factor nicely as x plus 7 times x minus 7. And when you set each of those factors equal to 0, you would get x equal negative 7 or x equal positive 7. You could write that as x equal plus minus 7 in like a condensed form like you see I have going on. It's still, a way to say that you got these two numbers here that are the solutions. Now, if we look at part B, it would not be easy to factor x squared minus 50 on the left, because 50 is not a perfect square. In other words, there's no counting number such that when you square it, you get 50, okay, like we saw over here with it being 49. So there's another method that we'll want to know, which is called extracting square roots, or sometimes we just call it the square root property. Okay, so if I were to rework the equation in part A, x squared minus 49 equals 0. If you add 49 to both sides, you get x squared equal 49. Okay, now I'm going to take the square root of both sides. The square root of x squared is x, and then I'm going to have the square root of 49 on the right. But here's the thing. Whenever you take the square root of both sides in an equation, you always need to make sure that you tack on a plus minus onto the right. Okay, now that's a mistake that students will sometimes forget about. Be sure that you remember to tack on that plus minus there. Of course, the square root of 49 is 7, so we still get x equal plus or minus 7, which is what we got over here by factoring. Okay, now I'd want to be using the square root property in part B, since this is not going to factor nicely. Okay, let's add 50 to both sides, and then we'll take the square root of both sides to get x all alone. Square root of x squared is x. Okay, I'll have plus or minus the square root of 50 then on the right. Again, you don't forget about the plus or minus there. Root 50 will break down nicely for us. If we use 25 times 25 times 2 is 50, and we know the square root of 25 is 5, right? So 5 root 2 would be the simplified form of root 50. And so my two answers are 5 root 2 and then negative 5 root 2. Okay, and I've got a plus minus, condensed form going on here. That's actually kind of a preferred way to give our answer, as rather than writing the two numbers out individually, which you could do, it's less writing to just write the plus minus. Of course, pay attention to any simplifying that would be there. Okay, if the radical breaks down, go ahead and break it down. Okay, simplify as far as you can go with all this stuff. So let's look at some more solving equations by extracting the square roots, okay, or just by using the square root property. So in this one, x minus 4 squared equal 12. Well, I do have a quadratic. Okay, now I'm not in the form ax squared plus bx plus c equals 0, okay, but I could rewrite this equation so that it could be in that form. Now I'm not going to do that because I'm already set up to take the square root of both sides, and I can get rid of that power of 2. Okay, but the point is that I could still call this a quadratic equation, because it could be written in that quadratic form there. So let's go ahead and take the square root of both sides. The square root of x minus 4 squared would be just x minus 4. And I'll have the square root of 12 then on the right. Of course, don't forget about the plus or minus. Add 4 to both sides since we're solving for x. And now root 12 is going to break down for us. 4 times 3 is 12, and the square root of 4 is 2. So 2 root 3 would be the simplified form of the square root of 12. Okay, so my two answers then, 4 plus 2 times the square root of 3, that'd be one answer. And then 4 minus 2 times the square root of 3, that'd be the other answer. Okay, and also, make sure that the answers are in exact form. Okay, we shouldn't need to do anything with the calculator. Of course, you can have a calculator, but don't do anything with like infinite decimals and rounding and stuff like that. Okay, because those are not exact numbers that they're looking for. Here's another one. Okay, now again, I'm already set up to take the square root of both sides because I can get rid of that power of 2 there. So that's what I've done. Take the square root of both sides. 2x plus 3 would be equal to plus or minus the square root of negative 5. You're going to subtract 3 and then divide by 2 in order to get x all alone. Now, I mentioned in the last chapter at the end that imaginary numbers will come up. Okay, and here's a situation where we see that. The square root of negative 5 in imaginary form would be I root 5. So my two answers are going to be the following. Negative 3 plus I root 5 all over 2, that's one answer. And then negative 3 minus I root 5 all over 2, that's another answer. Okay, again, you always have two answers with a quadratic. Now, so that we're all on the same page, okay, unless you're told otherwise in the problem, whenever you're solving an equation, if you run into a situation where there's a negative underneath the square root sign, just continue solving, and you'll give the imaginary solutions. Okay, like don't just stop and write no real solutions. Definitely don't stop and write no solutions. If you do that, you've completely missed the idea of what we just talked about at the end of chapter 9. Okay, there are solutions to this equation. We just have to know what, imaginary numbers are. So just, again, continue to solve and you'll just give the answers that would be in imaginary form there. Okay. Part C, solve for x. Okay, now, in this problem, I'd want to have the squared expression be all alone. So I'm going to begin by adding 17 and then dividing by 2. Okay, so I'm looking at 3x plus 1 squared equal 20. And now I'd like to get rid of the power of 2 there by squaring taking the square root of both sides. The square root of 3x plus 1 squared would be 3x plus 1. I'm taking the square root of both sides, like I said. And again, make sure that you attack on the plus or minus on the right. Now you're going to subtract 1 and divide by 3. Also, the square root of 20 is going to simplify as 2 root 5, right? 4 times 5 is 20. We know the square root of 4 is 2. So my answer in a complete simplified form would be -1 plus 2 root 5 all over 3, and then -1 minus 2 root 5 all over 3. Be sure that you simplify as far as possible. As I've already mentioned, if the radical breaks down, go ahead and break it down. Simplify as far as you can go there, okay, and keep the answer in exact form. Here's another one, okay, and again, I'm all set up to use the square root property here. Take the square root of both sides. That'll get rid of the power of 2 that we see on the left. And, of course, make sure that you have the plus minus there on the right. The square root of 49 over 25, well, the square root of 49 is 7. The square root of 25 is 5, right? So that, I guess, why don't I add 2/5 now to both sides? 2/5 plus or minus 7/5. Okay, I've got my common denominator is 5. So if I take 2/5 plus 7/5, that would be 9/5. That'd be one answer. And then 2/5 minus 7/5 would be -5 over 5, which is -1. That'd be the other answer. Okay, and we'll stop right here. In the next video, I'm going to talk about completing the square, which is another method for solving a quadratic.